Finishing our notes for lesson 6.2, day 1. We have that 45, 45, 90 specific triangle and the 30, 60, 90 specific triangle. Remember, we can measure our angles in either degrees or radians. That means 30 degrees is pretty much interchangeable with pi over 6 radians. 45 degrees, the same as pi over 4 radians, and then 60 degrees is the same as pi over 3 radians. We're going to focus specifically on sine, cosine, and tangent with these special angle rules. So because it's just sine, cosine, and tangent, we're going to think SOHCAHTOA. Remember that little mnemonic device that helps us remember the definition for each particular trig function. Sine of 30 degrees. What this tells us is that 30 degrees is going to be our reference angle or our theta value. Over here on the right triangle, I'm going to put that little 0 with a slash through it, that theta symbol. Remember, sine represents the opposite side divided by the hypotenuse. From that theta, the opposite side length is 1, and the hypotenuse is 2. What that tells us is that sine of theta is equal to 1/2. So let's go ahead and try a different measure. Cosine at 30 degrees, again, same idea, but now cosine is just a different measure. Cosine at 30 degrees would be the adjacent side divided by the hypotenuse. And remember, the adjacent side is the side that connects it to the right angle. In this case, we have square root 3. And then divided by the hypotenuse, we get 2. This is the exact cosine value at 30 degrees, or at pi over 6. As we move along, each one of these is going to interchange with the type of angle we start at and the definition that we have for that angle. So let's try tangent. I'm just going to get the arrows out of here quick. All right. So when we think about tangent, tangent at 30 degrees is opposite over adjacent. So opposite would be the 1. Adjacent is the square root 3. So what makes this kind of a little trickier is that we have to rationalize that denominator like we did, or like we'll do in many, many problems. So we'll multiply by square root 3 over 3. Oh, I'm going to move that over. Hang on. There, that gives me a little bit more room. So we'll multiply by square root 3 over square root 3, and this will eliminate the radical in the denominator. 1 times the square root of 3 in the numerator stays the same. The square root of 3 times itself in the denominator is positive 3. So these are the exact values for sine, cosine, and tangent at 30 degrees. Now we'll do the same thing again for 45 degrees. The unique thing about this 45 degree angle is that in that 45, 45, 90 triangle, there are 2 of them. It doesn't matter which one you pick because the comparison of the sides will be the exact same. I'll pick the angle that's at that bottom right there on the bottom left, and I'm going to consider that my new theta value. For sine, the definition is opposite over hypotenuse again. That would give us 1 over square root 2. And like tangent of 30, we need to rationalize this. I'll just multiply the top and bottom by square root 2 over itself, and that would give us square root of 2, and then on the bottom, the square roots cancel out, and we get positive 2. That's the exact sine value at 45. Now what's unique about 45 degrees is that cosine, since it's adjacent over hypotenuse, it's also 1 divided by square root 2. So that's going to equal the same answer as sine. Sine and cosine of 45 degrees is the same. Tangent at 45 degrees, remember that's opposite over adjacent. Now look at this. We have 1 divided by 1. That means tangent of 45 degrees is exactly 1. Last but not least, we're going to focus back on that 30, 60, 90 triangle with a reference angle at 60. So what I'm going to do is erase. Oh, it won't let me erase. Oh, that's unfortunate. All right, well, we'll try our best here. I'm going to go over to that 60 degree angle over here on the right-hand side. And now that's going to be my theta. So sorry for all the confusion on that. Let's see what happens. At 60 degrees, sine is opposite over hypotenuse. Notice the opposite side is going to be that square root 3. Ooh, that's in the numerator. That's good. divided by the hypotenuse, which is 2, so we can leave it in that form. So that's kind of nice. Cosine at 60 degrees is adjacent over hypotenuse. Remember, the adjacent side connects the angle to the right angle, so that's just going to be 1 divided, whoops, I want a different color. Whoa, let's get them to match up. All right, let's try that again. The adjacent side is 1 divided by the hypotenuse is 2. So notice the flip-flop from 30 to 60. Sine at 30 degrees matches with cosine at 60, and cosine at 30 degrees matches with sine of 60. Let's see what happens with tangent. Tangent at 60 degrees is going to be opposite over adjacent. That is square root 3 over 1, which simplifies to square root 3. Now these are going to be the 9 most commonly used answers you see throughout the rest of our semester. All of these fractions and integers and radicals are going to be embedded in multiple answers that we work with. So get to know them. This is going to be a great reference section throughout our semester. The last item we'll talk about in lesson 6.2 part 1 are the co-function identities. Now these are different from the reciprocals. So co-function identities are not just reciprocals of each other. It's just a different type of connection from one function to another. And the key on this is that prefix co, and you'll see what I mean in just a minute. Co-function identities represent complementary kind of grouping. So remember from 6.1, complementary means angles that add up to 90 degrees. So they represent complementary angles. Here's an example. Sine of 90 minus theta. So that means the complement for one value is going to be equal to the cosine. And that matched up above. Remember when we had 30 and 60? Sine of 30 degrees was the same as cosine of 60 degrees. So get this, sine, cosine. Interesting. And you can flip that around too. The complement for cosine is equal to sine. So you're not going to actually plug in an angle for theta. You're just going to recognize the complement kind of definition. Here's tangent. The complement for tangent is cotangent. And you can flip that around. The complement for cotangent is tangent. And then remember that SEC is secant. The complement for secant is cosecant, and vice versa. This is just kind of another comparison of trig definitions. They're all compared to each other in some way, shape, or form. So this is another way to kind of group them together. And you'll apply it with an example on the right. And it's going to require us to draw a triangle again. If we have the definition, if secant equals square root 13 over 3, find secant of 90 minus theta. So what we're looking for is the complement. Well, the complement for secant of 90 minus theta is over here on the right. That's the cosecant value. We see this definition over here. So we know that it equals cosecant. We just need to figure out how to calculate that value. So here's where a right triangle comes into play. Let's use this definition to create a right triangle. I'm just going to draw any old right triangle that I want and identify my right angle and identify my theta, just like we did in the video for the first part of this lesson. Now the definition of secant, since that's the actual reciprocal of cosine, is hypotenuse over adjacent. So if we think about that as hypotenuse over adjacent, the hypotenuse would be square root 13, and the adjacent side length would be the side length that connects the angle to the right angle. That would be at the bottom, which is 3. However, to get cosecant, remember that's the reciprocal of sine, we need the hypotenuse over opposite. So we need to calculate the length of that missing side length. How do we do that? Oh, funny you should ask. Pythagorean Theorem. Remember we follow that model a squared plus b squared equals c squared. A in this case will be 3, b squared we don't know. C squared is the square root of 13, but it's squared. Oops, sorry, I have 3 cubed. That's definitely not the Pythagorean Theorem. Here we go. Let's fix that, okay? 3 squared is 9, B squared we're going to keep for now. On the right, the square root of 13 cancels the squared, and we're just left with 13. It's pretty slick. We'll move 9 over. And we have b squared is equal to 4. Oh, perfect squares are awesome. Take the square root of each side. The length of that opposite side length should equal 2. And once you know that, cosecant, super easy. Cosecant of theta would equal the hypotenuse, which is the square root of 13, over the length of the opposite side, which is 2. And that's how you can use kind of those cofunction identities, embed them with our right triangles. Now, your assignment today is on Schoology. We're going to put that over here. This is going to be 6.2, day 1. The book pages are there. What I'd like you to work on are 5, 15, and 18. Those come from the day 1, the video that you guys watched for 6.2. And then 23 through 28 involves, that says all. Wow, that says all. All right, for 23 through 28, you're going to use that chart up above for the sine, cosine, and tangent definitions, and 23 through 28 is simply fill in the blank. So thanks, you guys. If you have any questions, please let me know.